everybody, and welcome back to another episode of Maths. Hope you're having a wonderful day. And today we are going to be continuing talking about improper fractions and mixed numbers, which was a topic we introduced in the last video. And we saw that these basically allowed us to express numbers that weren't just between 0 and 1 anymore, but decimals that were really big. We also saw we could do negative decimals. And we saw that basically a decimal could be represented by either an improper fraction or a mixed number. But now the question is, how do we convert between improper fractions and mixed numbers? Of course, we could kind of take the middleman strategy of starting with an improper fraction, converting it to a decimal, and then converting it to a mixed number, because we know how to convert both of these to and from decimals. However, that kind of is a little long and a little unnecessary, because there's a method that we can use to convert directly between these two. And the methods involve some things that we're already familiar with. Alright, so the first method we're going to look at is converting mixed numbers into improper fractions. So a mixed number basically had a whole number component and it had a fractional component. But we noted that this was basically a condensed form of 3 plus a quarter. And the thing is that we can do 3 plus a quarter and we can make it into an improper fraction right away, right? Because 3 is the same thing as 3 over 1. And we add it to a quarter. And we saw how to do this kind of thing in the previous video, where we have an improper fraction adding something else. So our common denominator is going to be 4, right? Because we can make this 1 into a 4 by multiplying it by 4. So we end up getting 3 times 4 is 12 over 4, right? 12 divided by 4 is 3, so this makes sense that it's an equivalent fraction, and then plus a quarter. And now we have the same denominator, so we can just add the numerators, and we get 13 fourths. So 3 and 1/4 is the same as 13 fourths, and this was the process. We just split up into its addition form and then did the addition to get our improper fraction as the result. Now some of you may learn kind of this little trick where you take the 4, multiply it by the 3, and add the 1. And indeed, if we do that, we do 4 times 3 is 12, plus the 1, we get 13, right? But that process comes from doing this, right? We multiplied the 4 by the 3 because that was part of us making this common denominator. And then we added the 1 because that was the part of the process of us adding the numerator of that fraction. So when you learn converting mixed numbers into improper fractions, that is one method that you'll do, denominator times the whole number plus the numerator. But this is why. This is what's really going on there. So I want to emphasize that. So let's try another one. So let's do 7 2/3 into an improper fraction. So this is the same thing as 7 plus 2/3. We want to make this 7 into a fraction so that we can make a common denominator. So this is 7 over 1 plus 2/3. We're going to multiply the numerator and denominator here by 3 each. So we get 7 times 3 is 21 thirds. Right, so now we have two fractions with this denominator of 3 plus 2/3. So we get 23 thirds. Equivalently, we could just do 3 times 7 and add the 2. 3 times 7 is 21, plus 2 is 23, and then make all of that over 3. But I think, again, this top process is a little more obvious as to what's actually going on, but this is unquestionably faster. All right, and let's try one with a negative. Let's do negative 11 and 4/11. We'll call that negative mixed numbers was doing the whole number and minusing the fraction, not adding it, right? So now to make this a common denominator, we can make this out of 1. And our common denominator is going to be 11, right? We can make 1 into 11 by multiplying the numerator and denominator by 11. So what's 11 times 11? You might recall from your times tables, that's 121, but there's a negative in there, right? So we need to make this negative 121. Oh, sorry, I should have done that in pink here. Negative 121. And then that's going to be over 11. Now we just have to subtract these, right? Negative 121 minus 4. They're both negative, so we just add them. We get 125, but it's negative, and it's over 11. So this is going to be the improper fraction from the mixed number. So it's a pretty straightforward process. It's really just an addition and a subtraction problem of improper fractions in disguise. So this isn't too bad to do. And let's move on to improper fractions converting into mixed numbers now. All right, so let's say we have an improper fraction like 12 fifths. All right, so 12 fifths, we want to express that as a mixed number. So we want the mixed number to have the whole number part and then the remaining fraction piece, right? And the fraction piece is not going to be an improper fraction. It's just going to be a regular fraction. So what we can do is we got to think, okay, 12 fifths, that's the same as 12 divided by 5, right? So we're going to, just like we did with converting it to a decimal, we're going to start by doing 12 divided by 5, the long division process. And let's see what happens. 5 can't go into 1, but it can go into 12 twice, right? Since 2 times 5 is 10. Subtract that off, we get 2. But now instead of going into decimals, we're going to just leave this 2. Because if we went into decimals, we're basically dividing this 2 by 5. But if we don't divide the 2 by 5 and we leave the 2, well, that is just going to be 2 fifths, right? So we can then say that 12 over 5, that's 2 with our remainder of 2. But we can write that remainder of 2 as basically this remaining 2 over 5. But that is exactly just a mixed number that we can write, right? 2 and 2 fifths. So essentially to get the mixed number, we divide it, and then the remainder is what we put inside of the numerator of our fraction out of the original denominator. So let's try another one to get used to that. All right, so let's do 103 thirds. So we're going to do long division of 103 divided by 3. 3 doesn't go into 1, but it goes into 10 3 times, right? 3 times 3 is 9. Subtract it off, we get 1. Bring down the 3, we have 13. 3 goes into 13 4 times, because that's 12, right? And then we subtract it off, we get 1. Now 1 is our remainder. So since 1 is our remainder, basically we have 34 as the amount of whole number times 3 can go into 103, and then there's 1/3 remaining, right? So this becomes 34 plus 1/3, which is exactly just 34 and a third as a mixed number. So let's try one with a negative number. Let's do negative 16 over 7. All right, so we can basically just leave the negative for after. So if we do negative 16 over 7, we'll just look at 16 divided by 7. 7 goes into 16 twice, right? We can subtract off that 14 and we get a 2. So this is going to become 2 with the remainder 2. But again, we have to remember that this is all negative. So 2, and then our remaining 2 is also going to be negative. So this is minus 2 over 7. Again, we're dividing this remainder by 7. But since we're not doing the decimal, we just leave it as this 2 divided by 7. And then this becomes negative 2, and 2 sevenths is the answer. So converting between improper fractions and mixed numbers is actually a fairly simple process. In the first case, we use common denominators, right, or Commy Dommies, as I will sometimes affectionately refer to them as. And for improper fractions to mixed numbers, it's just going back to division, but except going to decimals, we're going to just take the remainder. So it's actually easier than converting fractions to decimals, because we stop at the remainder. Alright, so I hope you found that video useful, and now you can convert freely between these two things. And you can also convert between decimals. So now we have pretty much 3 different ways of expressing these numbers. So that's kind of cool. And in the next video, we will get into doing some practice with this. But until then, you have a good one, stay groovy, and I'll see you in that next video.
Audio Jungle.
F.O.A. Maths.